Welcome to Session 2, Plane, Square, Cubic, and Degree Units. We will build the idea visually, solve a complete example, and finish with a short, independent check. By the end, you will be able to distinguish plane, square, cubic, and degree units by the quantity they measure. Convert every dimension to 1 unit before applying a formula. Use units to detect a correct calculation made with the wrong geometry formula. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The area is counted in square units. The volume is counted in cubic units. The angles are measured in degrees. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. Unit conversions grow with the dimension. Because 1 ft equals 12 in. 1 square foot is 12 times 12 equals 144 in squared, not 12 in squared. Likewise, 1 cubic foot is 12 cubed equals 1,728 in cubed. Units carry mathematical structure. Multiplying 2 compatible lengths creates square units, while multiplying 3 creates cubic units. A correct-looking number with the wrong unit answers a different question. Keep the quantity and its unit together from the first line to the final statement. That habit catches formula mismatches before arithmetic can hide them. Now add a precision check. If a diagram provides several dimensions, do not assume every number is needed. Circle the quantity named in the question, cross out unrelated information only after you can explain why it is unrelated, and predict whether the result should be a length, an area, a volume, or an angle. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, write the unit beside every given measurement. Second, convert unlike dimensions before multiplying or adding them. Third, carry the unit through the operation. 2 lengths multiply to square units and 3 lengths multiply to cubic units. Finally, check that the final unit matches the wording of the question. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. What unit type should be used for the surface area of a cube? Step 1 is to organize the information. Write the unit beside every given measurement. Step 2 chooses and sets up the relationship. Convert unlike dimensions before multiplying or adding them. Step 3 carries out the mathematics. Surface area covers faces, so it uses square units. A useful check is to units tell you whether you found length, area, volume, angle measure, or slope. The answer is square units. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. What unit type should be used for the capacity of a box? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is cubic units. Capacity is volume. A useful check is to units tell you whether you found length, area, volume, angle measure, or slope. Use this coaching check as well. If the number looks reasonable but the unit type is wrong, treat the answer as wrong and revisit the formula. Session recap. First, write the unit beside every given measurement. Next, convert unlike dimensions before multiplying or adding them. Then, carry the unit through the operation. 2 lengths multiply to square units and 3 lengths multiply to cubic units. Finally, check that the final unit matches the wording of the question. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.